Determine horizontal and vertical asymptotes. R of x is given as 5 plus 1 over x minus 2 to the power of 2. So let us look at the behavior as x approaches negative infinity. So when x approaches negative infinity, what happens to x minus 2? It is negative infinity minus 2. It's as good as negative infinity. And what is square of negative infinity? Again, very big number. And what is 1 over that very, very big number? 0. You agree that r of x as x approach infinity, r of x is going to approach 5. It is going to approach 5, correct? So let's substitute all the information that we have. Negative infinity is not a number, so we can only say that as it approaches negative infinity, what is 1 over a very big number, and that will be 0. And what is 5 plus 0? 5. So as x approaches negative infinity, value r of x approach 5. So what is the correct language to use? Limit as x approach negative infinity, r of x is equal to 5. Limit x approaching negative infinity, r of x equal to 5. So r of x equals 5 plus 1 over x minus 2 squared. As x approaches negative infinity, value r of x approach 5. Limit x approaching negative infinity, r of x equal to 5. The function approaches a constant value, y is equal to 5. That is a horizontal line. So as x approaches negative infinity, the function takes the value of 5. The function approaches 5. So 1, 2, 3, 4, 5. As x approach negative infinity, the function takes the value of 5. As you get closer and closer to negative infinity, the value of our function approaches 5. 1, 2, 3, 4, 5. R of x as x approaches negative infinity, and that is equal to 5. What happens when we go to the other side, positive infinity? As x approaches positive infinity, again we do the same thing. As x approaches positive infinity, do not forget infinity is not well defined. So as x approaches positive infinity, what is infinity minus 2? Again a very big number, and then square of that, and 1 over that becomes almost 0. So you get 5. So what is the correct language? As x approach infinity, value r of x approach 5. Limit x approaching infinity of r of x, and that is equal to 5. Function approaches a constant value 5. At what value? When x approaches positive infinity. So this is the horizontal asymptote, y is equal to 5. 1, 2, 3, 4, 5. But here the value of the function is more than 5. But as you go towards positive infinity, you see it is getting closer to 5. So y is equal to 5 is what we call the horizontal asymptote. Let's look at what happens when x is equal to 2. When x is equal to 2, this whole thing is equal to x minus 2 gets very close to 0. All right. For example, 1.999999999. That is a number that is very, very close to 2, but not exactly 2. So as you get closer and closer to x equals 2, what happens? The value of the function goes to infinity. So as x approaches 2, value r of x approach infinity. Correct language, as x approaches 2, r of x equal to infinity. Graph does not cross this vertical line x equal 2. This is x equal 2. So x equals 1 and x equals 2. The graph does not cross this vertical line x equals 2. X equals 2 is called the vertical asymptote. So here is x equals 0, x equals 1, x equal to 2, x equal to 2. What is the domain of our function? All the way from negative infinity to positive infinity. And where is the function not defined? At x equals 2. As x approaches 2, value r approach infinity. Limit x approaching 2, r of x equal to infinity. Graph does not cross this vertical line x equal 2. This is the vertical asymptote. The vertical line x equal 2 is called the vertical asymptote. What is the horizontal asymptote? Y is equal to 5. What is the vertical asymptote? X equal 2. And the George Mathew signing off. Good luck.